So the last section of Unit B mercifully does not carry on with that function bit. It's a little bit of a throwback to graphing equations, except for these are not equations. They're inequalities. So inequalities basically replace the equal sign with greater than or equal to or less than signs. So you might have remembered them as alligator mouths. So this would be 3 is greater than 2, or greater than or equal to, or less than or equal to. So this would be greater than, and these would be less than. So if you remember on that last section, there was a graph that had an open dot on it. That would be a case of y values greater than 1. If that dot was colored in, and I said let's not get too specific on it, it would be y values greater than or equal to 1 as the range of it. And so these are, pretty logical when you're dealing with numbers, right? So if you have to fill in the blanks, but we're going to be dealing with inequalities and algebra. And so there really is just one rule to remember, and I guarantee you will forget this at some point. So I don't know, maybe do something to remind yourself about it. Every time I teach this, I go back to the stuff that we know. And so we know that, say, 1 is greater than 2, right? Sometimes in solving equations, because I said inequalities are going to be a lot like equations, we're just replacing the equal to sign with one of these greater than or less than signs, right? Sometimes we divide by the coefficient to get x all by itself. So in this one, if I divide this side by -1 and divide this side by -1, take a look at what happens. I'd have -1 and -2. If I put this sign in between, is -1 bigger than -2? No. That is my clue that there is something funky going on. So when I do this solving equations, I have to reverse the sign. So if you multiply or divide by a negative number, you have to reverse whatever the inequality sign is. And like I say, up here, it's logical, right? But when you're moving around letters and numbers, you lose that sense of logic, and you lose that like double check. Does this actually make sense? So this is just a rule we need to remind ourselves of when we're dealing with algebra and these linear inequalities. So they look scary. They really are the same as what we've done. So I leave the sign in there, but I'm going to do everything that I normally would if it was an equal sign. So the idea to solve this is to get x by itself. So I'd subtract 4 from both sides. It would go away here. I'd get x is less than or equal to 0. That's solved. That's the solution. That would make this inequality happy. Like if I subbed it back in to make sense of it. You can't really verify these ones, but you can check different values on them. Let's just keep going before I confuse you too much with that one. The idea is that we want x, we want an inequality, and we want a number here. So I'm going to start by subtracting 2x from both sides. You can subtract things all you want. The exception was multiplying or dividing by a negative number. So I'd have 3x minus 2x would give me an x. I'm just copying my inequality sign, and I've got -4. That is my answer. So what that's saying is that I can take -4 or anything bigger and make this inequality true. This side would always be bigger than this side in that case. Let's keep going. So I divide by 5 to get this all solved, right, and get x by itself. So I get x is greater than 4. The next one here, if I were to solve this, I would solve x, and I get x is less than or equal to -3. keep going, I want numbers on one side and coefficients on the other. So I had -5 is less than or equal to 25. Here we have my rule. I'm going to divide by -5 on both sides. That means that I have to switch my sign. I'm just going to give myself a heads up here, right? I'm dividing by that negative number. I can do the math, but I have switched the sign. So I get x is greater than or equal to -5. Really, the whole point of doing this page is to practice some of that moving around and remember this rule that we have to enact. So more going on in this one. I'm going to pick on the x terms first because I tend to. I'd have 3x plus 7. These look scary when you first look at them, and then you realize, oh, it's all the same things other than this one exception, right? I'd have 3x, what's that worth? Oh, I copied a 35. I was going to say things are not working out here. I copied 34 as a 35. Sorry about that. There we go. That'll work. And divide by 3 and divide by 3. I get x is greater than 9 as an answer to this linear inequality. The last one, I got silly fractions, so just reminding how we got rid of those. You're doing the opposite always. I'd have 3x greater than or equal to -36. And I like doing this in 2 steps, so that's the way I've done it. I'd have x is greater than or equal to a -12. It was absolutely fine to be dividing a negative by a number. It's here, like when you're dividing by a negative number, that's when you need to switch the sign. So that's really the point of this page, to practice that we're doing that. Oops, I missed one down there. Let's do one more. I forgot to scroll all the way. So in this one, I'd like to get rid of that 4. And so I would multiply by 4 on both sides. I get -x is less than 20. And I haven't solved for x here, I've solved for -x. So I have to divide both sides by -1. That is enacting the rule. When you divide by a negative, you have to switch that sign. And then you can just keep doing the math, right? So I'd have x is greater than -20 as my answer. A bit of a spacing problem here, sorry, in my key. We're going to now take this and leverage it into graphing an inequality. So we've got this weird rule. We're moving things around, same as equations. We're going to go back to my favorite, the mx plus b form, right? So we're going to take our linear equality, put it into mx plus b form. Remember to enact that rule if in that algebra and rearranging, we have to divide by a negative, right? Then we're going to find the y-intercept and then another point from the slope. The key thing here is if there is an equal to sign, it's a solid line. And if it's no equal to sign, it's a dotted line. So much like that last example that I mentioned, the open and the closed dot, that's the difference when we're doing this is the difference when we're doing the graphing of the linear inequalities. The last part here is sometimes a little bit tricky. So basically with these, we're going to be shading a region of the graph. This is called the half plane. And basically, it's either going to be above the line for greater than or greater than or equal, or below the line for these. I like to think of the y values, but I'll show you on that one how that works. So here we have our linear inequality. And what we're trying to do is graph this. So the first thing I'm going to do is rearrange it to mx plus b form. So I have -3y is greater than or equal to -4x plus 12. Dividing by -3 on both sides, that enacts my rule. I have to switch the direction of my sign so that I can have y equaling 4/3 x minus 4. My y-intercept here is 0 and -4. My slope is going to be 4/3. So let's put these two on the graph. I'd have 0 and -4, And then this tells me to go up 4 and over 3 to get to my second point. Because it has an equal to sign, that's going to be a solid line, not a dotted line. And so I draw my solid line, almost straight. And then this business of the half plane, the solution to this is a bunch of numbers, right? That would actually make it true. It's less precise than an equation in a sense. And so this is saying the y values would be smaller than the line. This over here, hopefully in mx plus b, you're starting to recognize as the line. This whole thing, this would be my y values. So this is saying all the y values are going to be smaller than the line. So that's everything below my line, because those y values down here are smaller than my line. That's always a bit of a tricky one, and maybe my vocabulary is not working. Maybe you just have to go back to the notes and have that written down as a clue or a cue. But the way I said it is honestly the way I think about it. Let's try another one. So we've got a linear inequality. I'd like to write this in mx plus b form because I love it. So I'm going to take and subtract 3x from both sides. I'd have 2y is greater than or equal to negative 3x plus 6. I divide both sides by 2. It's not negative 2, so I don't have to switch that sign business. I'd have y greater than or equal to negative 3 halves x plus 3. That tells me my y-intercept is 0 and 3, and my slope would be a negative 3 over 2. So 0 and 3 is my intercept, and I go down 3 and over 2. I'm going to draw the line and I look back to the inequality sign. It's going to be a solid line that I draw because it has the equal to part of it. And then I have to do this funky half plane shading. So here I see, this is the way I think about it, this is my line, and this is telling my y values are actually bigger than the line. And so up here would be where y values are bigger than the line. And that could be solidly shaded in. I just don't have that. I guess I do have a highlighter, a coloring tool. In the homework answer keys, you'll see that they're actually like a solid plane when that half plane is shaded. So you're going to keep practice these ones. I put like a generous amount in the notes here because I find it takes a little bit of time. It also is a great unit to end with, because or section to end with, because it really does give you some more practice with this graphing with the mx plus b stuff. So I'd have negative y is greater than or equal to negative x plus 4, dividing by negative 1 on both sides. That enacts the rule, so I switch my sign. I'd have x minus 4 as my line then. That tells me that my y-intercept is 0 and negative 4 as an ordered pair, and my slope is going to be 1 over 1. So I'll go to my y-intercept, so 0 and negative 4, and then this tells me to go up 1 and over 1 to get to the next points. And you can keep going. That one's really easy to do. I'm not going to do too many more because they probably won't hit them anyway. And then the last bit, oh, that was a solid line because there was an equal to sign. And then the last business is shading the half plane. And so I've got y values are smaller than my line. I see this is my line. These are smaller y values. And so where y values are smaller would be down here. They'd be more negative. They'd be a smaller value as you move down that number line. Let's try this one, negative 2x on both sides. If you want to give this a whirl, you can go ahead and pause or fast forward the video. Like I say, there's lots of practice, which is why I put them in here. We'd have a y-intercept of 0 and 6 on this one. I'd have a slope of negative 2 over 1. So my y-intercept would be 0 and 6. My slope is down 2 and over 1. You can do that a few times if you want. And draw your line. Oh, it's going to be a dotted line. because it doesn't have an equal to part of it. So it's like, it's almost up to that line, but it's just a little bit short. And so that's why that's dotted line. And then this half plane. So the y values are smaller than the line. And so down here would be where the y values are smaller than my line. I find the half plane is probably the trickiest part of these. So just be patient. And again, that's why I've put lots of examples in here. Solving for y, I had y is greater than or equal to negative 3x plus 6. That gives me a y-intercept of 0 and 6 and a slope of negative 3 over 1. So I'd go to my y-intercept, I'd go down 3 and over 1. And then I could draw my line. It's going to be a solid line because it has an equal to part of it. And then this half plane shading. So y values are bigger than my line. And up here would be where the y values are bigger than my line. Okay, one more on this page. So I get it in mx plus b form, and then I go ahead and graph my y-intercept and my slope. It's going to be another dotted line because there's no equal to sign. I think on half of mine I have to go I draw my line, then I go back and erase it because I'm like, oh shoot, I forgot to look. And then this half plane business, this is my line and it says the y values are smaller. And so that would be down here where the y values are smaller than my line. More to do. Gives me a little bit of a clue on these ones. I just put them in because they do give you a chance to do more of this half plane shading. Oops. We've seen these kind before that go through the origin as like constant variation, right? So my y-intercept is going to be 0, 0. It's invisible on my equation. And my slope, really all I have is a rate of change here. So 0, 0, down 2 over 3, down 2 over 3. If I want to do it more than that, it's going to be a dotted line or a dotted line. That's easier for me to draw. And then this half plane shaded business. So I'm going to shade on this side of my line, the bottom side, where the y values are smaller than my line. We have to switch the sign if you divide by a negative. A lot of signs and fraction math in there, and switching a sign. So I can start with the point and do my slope. This is again going to be a dotted line. And I'd finish up by shading my half plane. The y values are bigger than my line, so I'd be shading that side of my half plane. Last two. This one is already in slope-intercept form. It's also in that constant variation format. Another little review for the unit for you. I'm going to have a solid line here. I feel like my lines are getting better. Still use a ruler. And then this half plane shading. Switch the sign when you divide by a negative. Start with your point. Solid line for the equal to inequality, and then shading that half plane. I see my y values are smaller than my line. I like this. I like it better if I have like a highlighter or something to use. The last ones, we're just going to roll this out. It's pretty straightforward, but we are going to give a little special attention to those vertical and horizontal lines. Make this a little smaller. They're pretty quick to do, right? We have all the options of less than or equal to or greater than or equal to. Basically, in graphing, x is less than or equal to 5. I would find 5 on my x. It's going to be a straight line at that point, a solid straight line, vertical line. And then the x values are smaller than that line. So this is where the x values are smaller than the boundary line there. And I would shade my half plane on that side of my vertical line. The horizontal here, again, you have all the iterations. We would have a horizontal line has the slope of 0. It's going to be a straight line at y equaling 2, or dotted actually, because it doesn't have the equal to sign of this inequality. And then really to complete this inequality, we have to shade the half plane. So here the y values are smaller than my line, and so I would shade that half of my plane on the coordinate plane. Awesome, that's it for Unit B. We're going to keep using all of this stuff as we roll into Unit C and keep dealing with linear equations, but next we're going to use more than one equation at a time in systems of equations.